What is finite element analysis? What are the stages and steps and applications in finite element analysis? What were the crucial moments in history of finite element analysis? Why finite element analysis? Why? What is it? What is the discretization? What is the Galerkin method? Hello guys, welcome back to my channel. If you are the one who is confused in order to know more about those things, then you have come really to the right place, guys. Welcome back to my channel about infographics, where me, Master Chintamani, an aerospace engineer and even an aspiring gynecologist, deal with a lot of this engineering scenarios and a lot of these methodologies used in the industry, guys. For the purpose of studying about engineering optimization and engineering visualization, and even in order to learn about learn about Tableau and data science, normally you have come to the right place. So guys, in this video, we're going to talk about finite element analysis, guys. So guys, this is one of my comprehensive series, about finite element analysis. One of the propagating series, guys, in a comprehensive approach. So in case if you have not really subscribed, if you have not still subscribed to our channel, if you have not liked it, please do that. So guys, in order to deal with finite element analysis, guys, okay, let's basically break that entire concept, guys. The definition of finite element analysis: 1. The important stages and applications of finite element analysis; 2. The development of finite element analysis; 3. The history of finite element analysis; 4. And the industrial applications of finite element analysis; and 6. The softwares you require for finite element analysis. So guys, as I've already told you in the past all video graphs, what finite element analysis really means, or what finite element analysis is, guys, is basically a methodology, guys, used, guys, for the purpose of structural optimization in engineering. So what finite element analysis is guys, it's basically a methodology, or rather a modus operandi, guys, which is basically used to study some of the problems, guys, in engineering, guys. Some of the scenarios, which take place in the domain of engineering, or rather the problems, which basically happen to be of the electromagnetic potential, or about the structural analysis, or even about the heat and mass transfer and stuff. Those are the problems which are studied with the inner systems of the finite element analysis. And even guys, some of the things, guys, related to the leaning tower of Pisa, guys, and why it did not collapse. And number one is basically a stress composition, guys, caused by the so-called slanting, or rather so-called curvilinear failure, guys, of the leaning tower of Pisa in Italy, guys. And what are the effects, guys, and what it's causing, guys, on the ground, or rather on the soil, or whether is that even going to fall, or rather why it does not collapse, guys. And those are the things which are basically dealt with the inner systems of the finite element analysis. So guys, finite element analysis is simply a methodology, guys, which basically employs the so-called code of discretization, guys, when it comes about studying a problem, guys. And in order to do that, guys, what it actually does is that and so-called element, guys, whichever we got to study, guys, is basically break down and divide it, divided equally, guys, into small equal parts and stuff, in a maybe in a graphical manner, guys, and those all smaller and smaller elements, guys, which are basically which we basically find, or which we actually get after dividing it, guys, are in fact used for the purpose of are in fact used for studying it. And guys, the graphical coordinates are even assigned, guys, to all those elements, guys, such that, guys, those all elements, should be very well recognized, guys, So for that, guys, coordinates are even assigned, guys, to all those smaller elements. And the other thing, which I gotta say is that when it comes about finite element analysis, guys, primitively, it uses the differential equations, guys, especially the partial differential equations, guys, to study a problem. So, guys, why the partial differential equations are used are what we're going to study, towards the end. Please do not skip this video. So, guys, why partial differential equations are used is, for the purpose of mathematical modeling, and for the purpose of breaking down that so-called object, guys, And number one, with due respect to different directions and different phases, guys, of that so-called object, whatever that object or whatever that substance might be, maybe a car crash, or maybe oil leakage in a pipeline, or maybe fall of a comet, whatever. But all those problems, guys, are studied, with the inner systems of finite element analysis. So what that thing, really means is that it basically breaks down, breaks down that object, guys, in such a manner, guys, which basically, which makes it more and more easy, guys, to study that engineering scenario, guys, in a greater precision. And if you gotta know, guys, if you gotta know about the domains and the real applications of finite element analysis, guys, and it happens to be in it happens to be in all sorts of domains, guys, such as the geophysics, such as even the civil engineering and aeronautical engineering, and even, guys, even for the purpose of infrastructure development, guys, when the civil engineers, basically offer construction of large scale infrastructure, or rather megastructure projects. It's even used, guys, in hydraulic engineering, guys, to study the flow of water, and to study as to what how exactly that dam is going to work, or how exactly that dam is going to resist itself, from breaking. So those all things, guys, are studied with the applicability of the finite element analysis. And guys, what it actually does is that all these domains, guys, when we think about even a geothermal engineering, guys, for instance, guys, all these domains, guys, are basically having a great applicability of that finite element analysis, guys, in its entirety. And guys, when it happens to have even another method, guys, of so-called slicing, guys, with the methodology of slicing, is used, guys, to slice down the object, or rather to slice down the object, virtually, in a three-dimensional graphic, computerized simulation, guys. So, guys, when that is done, you can, in fact, study a so-called scenario, so easily. And that is what, is really fundamental, guys, for our engineers nowadays. Guys, because you cannot simply, perform all those really rigorous and really hazardous and really mammoth, or rather elephantine projects, guys, in reality, guys, which obviously requires a lot of resources, a lot of monetary potential, and it's basically exploitation of a lot of industrial resources, guys, just simply, for the purpose of, testing those things. Now these things, guys, can be very well, helped, and these things can be very well solved, with the inner systems of the three-dimensional computerized simulation, guys, which is basically performed by the finite element analysis. So, guys, basically, for all these things, guys, this so-called methodology of finite element method is used. And guys, if you gotta think about the so-called establishment of the finite element analysis, like how it came into existence, or who is basically the one who basically established that so-called methodology, you'll be surprised to know, guys, that there is basically no single inventor credited for finite element analysis, like Newton, as inventor of the calculus. Now, obviously, there happen to be some another theories, which say that even the scientist, or rather mathematician Leibniz, was even credited, with the invention of calculus. But many people, believe it to be the Isaac Newton. But guys, what I gotta say is that when it comes about finite element analysis, its roots can be traced down back, guys, literally to the times, guys, of 1920s, guys. Where basically vast scale projects and stuff, were basically performed. And guys, those were the times, guys, where four of the greatest ever mathematicians, or rather four of the greatest ever technoscientific individuals, named as Professor A.U. Courant, Professor A.R. Clow, Professor A. Renikoff, and even Professor Ray. Professor Ray, guys, came to not exactly came together, guys, but started developing some of the methodologies, guys, which would basically would have helped them, guys, to help them, to perform the engineering visualization of the problems, guys, and even for the purpose of the optimization of the engineering problems. So guys, that is how they came up with that so-called methodology of the finite element analysis, and that is how guys it was done. But guys, finite element analysis, has got seriously great advantages and seriously great applications as well. Guys, that finite element analysis, guys, can be used as a great industrial tool, guys, even to perform some of the greatest ever calculations, guys, even in aerospace engineering. Like, guys, if you got to study the Hornet, guys, the flight of that so-called aircraft named Mr. Hornet, the aircraft named Hornet, how it basically flew, or how can it basically propel itself to that hypersonic speed. Or what about the X-43 of the NASA? What about the North American X-15, guys? About all those aircrafts, guys? But basically the finite element analysis is even used, guys, in the development as a key element, guys, for the development of all those aircrafts, even to perform all those experimentation, guys, about its turbines, guys, in the heat laboratory, in the heat engine laboratory, and even, guys, in order to basically know us, how that fuselage is basically gonna restrict itself, guys, from being bent, or from having a dent, guys, through the external forces, guys, when that aircraft, is basically traveling at the hypersonic speeds, guys, or even at the supersonic speeds. Basically, when we talk about hypersonic speeds, guys, there are very few vehicles, guys, few vehicles around the aeronautical entities, guys, which basically can do it, like the X-43A, even the North American X-15, even all the re-entry vehicles, and one spatial, guys, when it re-enters back, obviously. But guys, what I gotta say is that when it comes about that, guys, all the heat testing and stuff, guys, of that aircraft, or even about the analysis of that turbines and stuff, guys, in the laboratory, guys, it's performed with the aid assistance of the finite element analysis, guys, and which basically helps the scientists and engineers, guys, in a great manner and in a great way, guys, to basically explore the areas of difficulties, guys, areas of difficulties around it really helps them, guys, to even explore some of the anomalies, guys, which are basically caused, while those so-called equipments, guys, are simply at their best potential. Even you can take into consideration, guys, you can take into consideration, guys, for example, guys, the case of a bird, guys, striking the turbine of an aircraft, guys, while that aircraft, guys, is basically in its initial ascent. So, guys, even the bird strike to an aircraft's turbine and stuff, and the damages and the potential hazards, guys, which it can cause to that so-called airborne vehicle, that aircraft, which is obviously airborne, guys, even those things, guys, are performed even by the statisticians, guys, by the aid assistance of the finite element analysis. Even, guys, it has got great applications, guys, in military and industrial hardware, guys. Basically, all of the attacks, guys, all of the attacks, guys, even the launching of the interballistic missiles, and even all those attacks, guys, which basically take place, guys, while there is a war between two countries, guys, can even be performed, in a greater precision and a greater approximation, guys, with the aid assistance of the finite element analysis. So, that is really a neoteric tool, guys, which basically helps scientists, guys, to explore as to what is the extent, what is the most abysmal, or rather most disappalling extent, guys, extent to what a problem can be cataclysmic, or rather where it can be devastating, guys, So, finite element analysis, guys, as a tool, guys, really, helps you guys, to explore those things. And, guys, which is why finite element analysis, guys, in its entirety, is developed as a so-called equipment, guys, as a so-called code, guys, as a so-called methodology, guys, which is really crucial for our engineers and our fellow scientists nowadays, which is seriously unstandard, which is used in the industrial engineering. Now, guys, what else about finite element analysis is, guys, it obviously requires the applications of the partial differential equations, guys, to perform those mathematical calculations, guys. So, guys, those all things, guys, are done and studied efficiently, guys, by the finite element analysis. And obviously, Professor Clow, Professor Renikoff, even Professor Ray, guys, were some of the key individuals, guys, some of the American scientists, guys, who were who are basically, credited, guys, credited in a consociation, guys, for the development of that so-called methodology of finite element analysis. Now, obviously, it had got multiple names, guys, back in those days, But one thing, which is stayed constant, guys, is the applicability of calculus of variations, that methodology, and even the meshing. It was initially known as the meshing discretization, after which, it came to be known as the finite differences method. And then finally, it was known as the finite element analysis, or rather the finite element methodology or method. And guys, that is how, guys, the beginnings of the finite element analysis, took place, guys, back in 1930s, guys. And obviously, Professor Renikoff, Professor A.J. Clow, Professor Ray, and even Professor Courant, guys, were the people, which were basically, responsible, guys, for the purpose of implementation of that so-called scheme of finite element analysis. And guys, what it does is, guys, in order to basically, study boundary value problems, guys, linear algebra and even the coordinate geometry, guys, is basically geometry is used, guys, for the purpose of, solving or rather analytics, guys, of the boundary value problems in the finite element analysis. And what that clearly means is, guys, that finite element analysis, is emerging out as a really great and really advanced industrial tool, guys, which can basically help the young scientists and engineers, guys, to explore the full potential, guys, when it comes about risk assessment and even disaster management. And guys, lots of eventualities and lots of calamities, guys, also, can be corrected and, can be even eliminated, guys, through the inner systems of the finite element analysis, guys, such as the aerospace crash, such as the air crash, such as even so-called the prevention of the fall of the meteor or fall of the garbage, which is basically, present in the belt, guys, or rather the extraterrestrial garbage, which is basically left out, guys, by rockets and stuff, guys, or rather, the so-called separating stages of rocket, guys, which basically, keep orbiting, guys, in the belt of the Earth, guys, and which, obviously, always, having great potential or and great proclivity, guys, to protrude themselves, guys, towards the Earth's gravitational orbit, guys, and then get intensely sucked, guys, sucked to the land of the Earth. So, guys, those all things, guys, can be very well eliminated, through the inner systems of finite element analysis. And by the way, guys, even the aerospace engineers and even the electronics engineers at the International Space Station use the finite element analysis, guys, to study the extravehicular walk, guys, performed by great astronauts like Sunita Williams and stuff. And obviously, those are the things, which are used, which are basically the applications of the finite element analysis. And guys, what it basically means is that finite element analysis, has already emerged out as an industrial tool, and which requires the usage of the differential equations and partial differential equations. It can perform the engineering visualization. It can even perform the mathematical modeling of a problem. It can basically break down a problem, guys, into fundamentally equalized and fundamentally small elements, guys, in order to perform that optimization. It can basically help you to perform real computerized, virtualized simulation, guys, of an so-called calamity taking place. So, which can be cost efficient. It can save a lot of cost. It can even save you, from those industrial hazards, guys, often so-called atomic catastrophe, guys, which is even caused, guys, basically, which was caused, guys, not accidentally, intentionally by the United States by launching an atomic bomb on Japan, Hiroshima and Nagasaki. But guys, nowadays, even all those nuclear testings and stuff, whatsoever are taking place, guys, can be even very well analyzed and even very well performed, with the inner systems of the finite element analysis. And guys, which is why finite element analysis is really, emerged out as a greater industrial tool, guys, to study all those problems, to perform those simulations and stuff. And finite element analysis, guys, finally, requires the usage of those so-called methodologies, guys, of meshing and discretization, guys, in order to basically, break down problems, guys, such as the boundary value problems. And some of the two major approaches, guys, in finite element analysis, guys, are known as the Galerkin approach and even the Rayleigh-Ritz approach. And even, guys, the Laplacian transforms, or rather even the calculations based on Laplace transforms, guys, are basically used for the purpose of the mathematical analytics, guys, or analysis, guys, of the finite element analysis. And even the Runge-Kutta method, guys, is basically used in finite element analysis, guys, and to perform the three-dimensionalized computerized simulation, guys, of all those events. And guys, when it comes about a car testing or a car crash and stuff, or an accidental vehicular collision, guys, or an inter-vehicular collision, guys, between two of the vehicles, guys, those things are very well basically performed with the intersections of the finite element analysis, guys, so these all seem to be the applications. And as I told you, the Professor Rennikov, Professor A.J. Clow, Professor A.U. Courant, and even Professor Ray, guys, were basically credited, with the implementation of finite element analysis. And obviously, differential equations and PDE, partial differential equations, are used, for performing and solving real boundary level problems, guys, through the inner assistance of the finite element analysis. And softwares like TensorFlow also are used. And finite element analysis has therefore emerged out as a great tool in the industry, guys, for the purpose of solving those great problems, solving those really hazardous and rigorous problems. And obviously, guys, those all people are credited with that. And what else, guys? Meshing and discretization, guys, is basically even performed, guys, when it comes about breaking down a problem, guys, into different elements, guys, basically, by fundamentally, slicing down a particular object, guys, in order to basically study and to perform the virtualized, three-dimensionalized, computerized simulations of it. So that is about finite element analysis. And obviously, for more updates, guys, stick up to my channel soon. And guys, in order to learn more about Tableau and even data science and even about so-called lab-grown meat and even about gynecology, guys, please just stick to my channel, and I'll be more than happy and more than privileged, guys, to share that stuff with you in the following lectures and in the following programs. See you, and Jai Hind, and bye-bye, guys, and Jai Bhavani, Jai Shivaji. Bye.